Today we're going to work on completing the square. And completing the square is a method used for two things. One, use it to solve the quadratic. Two, you use it to take the quadratic that's in standard form and rewrite it into vertex form. This is another way to do that. There are two ways to do that. One of them is the one we use today, find the vertex, and then rewrite it in vertex form from that. There's also done using the square. Now, completing the square is probably one of the more difficult things to do. We're solving an equation. We're solving a quadratic. I honestly do not like it. We're solving a quadratic. I would rather solve by factoring. That's my first choice. And my second choice is the quadratic formula, which is not pleasant either. However, completing the square for things other than solving is important. And I will give you a step-by-step how to do completing the square when we start doing those in a little bit. I have a step-by-step procedure. If you write it down and if you learn and understand that step-by-step procedure, using completing the square is simple. If you don't, it's really difficult. Completing the square is not an easy method to use. You're going to have to pay real close attention today. So we're going to start, however, with the square root property. A method to solve a quadratic equation by isolating the squared term and taking the square root of both sides. We're going to start with that simply, and then we're going to use this as part of doing completing the square. Okay. Any questions? Okay. All right, so here we go. Solve by taking the square roots. So we worked yesterday or the day before solving by factoring. And we can solve this first one by factoring. Okay, a plus 3, a minus 3. Those are your factors. Set them each equal to 0. Solve for there. If you have the situation where you have one variable only, and it's squared, you don't have anything else, you can use the square root property instead. Your first step is to get whatever squared, whatever term has the square in it, get that square by itself first. So my first step in solving this without factoring, and actually works well with these particular types of problems, is to add 9 to both sides. A squared is equal to 9. Now, when I have my square equal to a number, and it's just the variable squared, I want to get the variable by itself. You undo a square by taking the square root. Squaring and square roots are inverse operations. Get rid of the square, I square root both sides. A equals, what's the square root of 9? 3. However, I need to have plus and minus 3, both of them. Because not only does 3 work in that problem, but so does negative 3. When we solved this the other day by factoring, we got plus 3 and minus 3 both as an answer. You must have plus and minus. If you do not have the plus and minus, it will be wrong. You must have the plus and minus or it will be wrong. Because if I take 3 and plug it in the original problem, 3 squared is 9, 9 minus 9 is 0. Put negative 3 in there. Negative 3 squared is also 9. 9 minus 9 is also 0. I have two solutions, plus and minus 3. You must have the plus and minus when you do this. That's an extremely important part that will go through the entire day, having that plus and minus. Next one, same step. First one, add 75 to both sides. 3n squared is equal to 75. I want to get my square by itself first. So my next step is to divide both sides by 3. and I get n squared equals 25. I have I have my squared variable. My next step is to square root both sides, and I get n equals plus or minus 5. Okay, plus and minus 5. Okay. 4h squared equals 9. My first step is to get the h squared, so I divide both sides by 4. H squared equals 9 fourths. Do not, unless it divides evenly or reduces evenly, do not rewrite it as a decimal or a mixed fraction. So I get h squared by itself. So I square root both sides. And I get h equals, now the square root of a fraction is the square root of the numerator over the square root of the denominator. Square root of 9 is 3, square root of 4 is 2, so I get plus or minus 3 halves. Okay, they're perfect squares, just take the square root of the fraction. Square root of 9 is 3, square root of 4 is 2, 3 halves. This one, divide both sides by 2. W squared is equal to 10. Square root both sides. W equals, is 10 a perfect square? No. Plus or minus the square root of 10. Not some 3.1 blah, blah, blah. Do not take the decimal on your calculator and give me that. I will be very angry. This is exact. The square root of 10 is exact. If you were to take the square root of 10 on your calculator and give me a decimal, that would be an approximation. And I want the exact answer, not an approximation. Your turn. Do those. Okay, these are relatively quick and easy. Shouldn't be too bad. First one, add 64 to both sides. I get x squared equals 64. Take the square root of both sides. X equals plus or minus 8. Next one, add 98 to both sides. 2p squared is equal to 98. Divide both sides by 2. P squared is equal to 49. Square root both sides. P equals plus or minus 7. Okay, this one here, divide both sides by 16. G squared is equal to 25 over 16. Square root both sides. G equals plus or minus 5 fourths. And last one, add 15 to both sides. 3b squared is equal to 15. Divide both sides by 3. B squared equals 5. Square root both sides. And B equals plus or minus equals, B equals plus or minus the square root of 5. Any questions? Not bad. We are going to be doing similar things when we do completing the square. Okay, so you do not have a blank space for this. On the next section is not blank for these notes. Put these on the summary or on the last page of the notes for this section. Get this written down. This is your step-by-step procedure for solving by completing the square. If you follow the step-by-step procedure, if you learn the step-by-step procedure, this is easy-ish. If you don't follow this step-by-step procedure, if you don't learn this step-by-step procedure, you're never going to get it. It's one of the things. It's normally I don't like to give stuff like this because normally it doesn't really apply that well. It does for this. This one is a procedure to use. It's the same procedure all the time for a couple of reasons. One, you'll never have anything in front of the x squared, so you don't have to worry about dealing with that crap. Okay. And two, it's the same steps every time. Just the numbers are changed to protect the answer, so to speak. Step number one, move your variables to one side and constants to the other, leaving a blank space. What do I mean by a blank space? Well, for example, after moving things around, you would have something like x squared plus 6x, and it would be like equal to 12 or something like that. What I mean is you want to leave a blank space here between your x terms and your equal sign because you're going to fill in that blank spot. That's what I mean by leave a blank space in there. And then you're going to have it filling in on the other side, but you're just adding the other side. You'll leave a blank space. You do need one between where your x's are and your equal sign because you're going to have to fill that in. And then the next step is complete the square, which is the hard part. What am I going to put in that blank? Well, actually, it's not that hard to do. The thing that you're going to put in the blank, the square you're going to add in the blank at both sides, is b over 2 squared. Half of b and square it. That's what you're going to add to both sides to complete the square. Rewrite it as a perfect square. Okay, that means that you're going to have x plus or minus something squared. You're going to take that trinomial and rewrite it as a perfect square. That something is also easy to find. That something is the b over 2 that we squared. And then you're going to take the square roots of both sides, just like we did. And then you're going to have another step to finish solving the problem. Okay, but this is the step-by-step procedure for solving, completing the square. First step, all your x's on one side, the squares and the non-squares, space equals everything else. Rearrange as needed. Complete the square. Half of b, square it, and that's what you add to both sides. Take that trinomial you now have, rewrite it as a perfect square. And then square root both sides, and then make your final step towards solving. Okay. Any questions on this? So, let's apply that. First step. All the x's on one side, numbers on the other. So what do I want to do? I add 1 to both sides. X squared plus 6x blank equals 1. And then I'm going to have a corresponding filling in the blank on the other side. So whatever I add to one side, I need to add to the other side. Now, what do I put in that blank? Half of b squared. What is b? 6. What's half of 6? 3. So I'm going to take half of 6, square it, so I get 3 squared, that gives me 9. I add 9, and it's always plus. I add 9 to both sides, thus completing the square. That is actually the part of completing the square. I now have a perfect trinomial square on this side. This is a perfect trinomial square now. Half of this squared gives me what I need to add to get a perfect trinomial square. Now I need to write that as a perfect square. And I have x. And what did I square to get 9? I squared 3. Take half of this and square it. So what do I have down here? Half of this is what I put in. The number I squared is what I have here. What's half of 6? 3. X plus 3 squared. This and this are the same thing. They're just written differently. Equals 10. Complete the square. Rewrite it as a square. Now I have a perfect square equal to a number. This is just like the problems we started with. Well, not just like, but it's at the same step. Something squared equals a number. How do I get rid of the square part? How do I get rid of this? I square root both sides. The square root of a square is just whatever I'm squaring. X plus 3 equals plus or minus 2 square root of 10, because 10 is not a perfect square. If it was a perfect square, then this problem would have been factorable to begin with. Okay. And I don't care if it is factorable. Some of the problems might be factorable. I don't care. If it says solve by completing the square, you need to solve by completing the square. Do I have x by itself? No. So what do I need to do now? I need to subtract 3 from both sides. Subtract 3, subtract 3. X equals -3 plus -3 plus or minus the square root of 10. That's my answer. -3 plus or minus the square root of 10. You want to have your single number by itself, plus or minus whatever you've got on the other side, in that order. You don't want to have plus or minus the square root of 10 minus 3, because that means all kinds of things. If I have, instead of this, I had plus or minus root 10 minus 3, is that plus the square root of 10 minus 3 as a whole, or minus the square root of 10 minus 3 as a whole? Is it plus or minus this whole thing? Figure out that number, plus and minus that. Or is it -3 plus root 10, -3 minus root 10? If I put the plus or minus in the front, I don't know the difference. And these are not the same as this. That's why you put the 3 and then the plus or minus whatever afterwards. Because how many answers do I have? I start with the square. How many am I supposed to have? 2. I have 2 answers. -3 plus root 10, -3 minus root 10. Those are my 2 answers I have. If you do it step by step, it's easy. If you don't do it step by step, really, you're not going to get it. First step. Y is on one side, constants on the other. Subtract 3 from both sides. When you rewrite it, leave a blank for the work. I need to fill in that blank. I need to complete the square. I take half of b. This is b. Half of -8 is -4. I square that, I get 16. So I add 16 to both sides. Yes?
You said it's always positive, so if it turns out negative.
What I add is always positive. This may be negative at some point. We're going to deal with that at another time. I don't think that happens to anything we're doing in here today, but that's where I comes in. Yeah. Don't give me that one. Okay. But we won't deal with that today. We will deal with that later. Okay. So yeah, this is always positive because I take a negative and square it. What do I get? I get a positive, right? So now I have to rewrite it. Y something squared is equal to 13. Just go ahead and simplify the other side. What do I have? I have y what? What do I stick in there with it? -4. Half of the -8. Half, whatever I squared to get 16, I put -4 in there. The item that I squared, that's what goes in. Now I square root both sides. And I get y -4 is equal to plus or minus the square root of 13. I need y by itself, so I add 4 to both sides. Y equals 4 plus or minus the square root of 13. Okay, so let's do the next one together, step by step. Do the first step. Don't go past the first step. Don't try to do the whole thing. Just do the first step. I want to make sure you can get this right, step by step. So my first step, this is what you should have done. Add 7 to both sides. And I get v squared minus 4v blank equals 7. Okay, fill in the blank. So I take half of -4 and I square it. What do I get? What goes in the blank? +4, because it's what I square, right? I have to square it. Half of -4 is -2 squared, I get 4. And if I add 4 to one side, I need to add 4 to the other side. Now rewrite it as a square. You get v minus 2 squared, because after -4 it's -2, that's what I squared. And go ahead and finish it off. From here it's easy, the hard part's done, relatively speaking. And so you should square root both sides. V minus 2 is equal to plus or minus the square root of 11. Add 2. V equals 2 plus or minus the square root of 11. Flex to the next one. Go ahead and do the first step on the next one. Oops, I forgot to do something important on mine. I forgot to leave a blank space. All right, now the fun begins. What do I want to put in the middle to complete my square? No, I do not want 2.5. There's a good reason I don't want 2.5, but you're on the right track. Don't make it a mixed number. Mixed numbers in algebra should only be used when you're answering a word problem. How many pizzas do I have? I have 2.5 pizzas. That's a good answer for a word problem. Allows you to work with. So what should I have instead of 2.5? I should have 5 halves. Leave it as a fraction. Don't make it a decimal. Leave it as a fraction because you start with a whole number, so you should have it. So yeah, I take half of b and I square it. Now, I'm not writing 5 halves in there, but I am taking half of b, so I have -5 over 2. And what do? I square that, right? That's what I don't put in there. I don't put in 5 over 2, but I square it. But you're on the right track. I want to do that. I take half of whatever that is. Now, the other ones were all even, so half of whatever they were was a whole number. This is a fraction. I square it. When I square a fraction, what do? Square the numerator, square the denominator. So what do I add? I add 25 fourths. I add 25 fourths to both sides. Oh, this is not going to be pretty. I don't care. All right. Well, this next step isn't too bad. I have m, and then half of 5 is -5 halves equals $17 fourths, I believe. Let's do this over here. Work over on the side. I have -2 plus 25 force, 25 force, which means I have -8 force plus 25 force, right? Common denominator when you're adding fractions. And then 25 minus 8 is 17, right? 25. Yeah. So that gives me 17 fourths, right? When you have combined fractions, you have to have a common denominator. And my next step, I got to get rid of the square, so I square root both sides. And this side's easy, m minus 5 halves equals, the other side's not as easy. Plus or minus the square root of 17 fourths, which is plus or minus the square root of 17 over the square root of 4, which is plus or minus square root of 17 over 2. And you do want to do that. I know, it's not pretty. Life's not always pretty. Add 5 halves to both sides, and I get m equals 5 halves plus or minus the square root of 17 over 2. Now, does that kind of look familiar to you? If I rewrite that as one fraction, m equals 5 plus or minus the square root of 17 over 2. Does that help make it look real familiar to you? That looks like a quadratic formula answer, doesn't it? The quadratic formula comes from completing the square. You use completing the square to come up with the quadratic formula. That's where it came from. They used completing the square to create the quadratic formula. That's where it comes from. Completely. They just use A, B, and C instead of specific numbers and used completing the square to solve it. That's where the formula comes from. Your turn. Do those. Okay, so let's go ahead and do these. First step, subtract 8. C squared minus 10c equals -8. What do I add? Half of -10 is -5 squared. I get 25. So I add 25 to both sides. That gives me c minus 5 squared is equal to 17. Square root both sides. C minus 5 is equal to plus or minus square root of 17. Add 5. C equals 5 plus 17, not 16. Plus or minus square root of 17. On the next one, I add 9 to both sides. V squared minus 2v blank equals 9. Half of -2 is -1. Square that, I get +1, so I add 1 to each side. Plus 1 plus 1. V minus 1 squared is equal to 10. Square root both sides. V minus 1 is equal to plus or minus the square root of 10. Add 1 to each side. V equals 1 plus or minus the square root of 10. Questions on those top two? So I'm going to scroll down to make more room. Okay. Add 1 to both sides. K squared plus 6k blank equals 1. Half of 6 is 3. Square that, I get 9, so I add 9 to both sides. And I get k plus 3 squared is equal to 10. Square root both sides. K plus 3 is equal to plus or minus the square root of 10. And then I subtract 3 from each side. So k equals -3 plus or minus the square root of 10. And now for the fun one. Add 5 to both sides. H squared plus 3h equals 5. I get 3 over 2. Square that, I get 9 over 4. So I add 9 fourths to both sides. This becomes h plus 3 halves squared equals 5 plus 9 fourths. Common denominator would be 4, so this is 20 fourths plus 9 fourths gives me 29 fourths. Square root both sides. And I get h plus, just plus only, h plus 3 halves equals plus or minus the square root of 29 over 2. Square root of 4 is 2. So I want to simplify my denominator. And then subtract 3 halves from both sides. H equals negative 3 halves plus or minus the square root of 29 over 2. And you can leave it like that. You don't need to make it into one fraction. The only reason I made it into one fraction is to make sure that you understood, ooh, this is where the quadratic formula comes from. Like I said, if you follow it step by step, if you learn those steps, this is easy. You don't learn the steps, you don't memorize the steps, this is really difficult. I can always tell when I test who's bothered to memorize how to do this and who has not. Those that get it all right, obviously have done it. Those that are close and have most of the steps down have tried. And then there are those that have no freaking clue and there's guessing going on, and I can tell when guessing goes on because they didn't bother to do it. Yes? It's half of this squared. Yeah, half of that squared. So I take whatever half of b is, square it, and then what goes here is the half of b. What did I square to get 9? Okay. Rewriting it in vertex form by completing the square is nearly the same thing. Nearly the same thing. A couple of, it's actually, I think, a step less or 2, but it's nearly the same. Your first step is to don't move the 10 to the other side. Your first step is to just move the plus 10 over, leaving a blank space. You don't move it to the other side, you just move it over and leave a space. Y equals x squared plus 8x blank plus 10 and blank. We're actually going to put stuff in both blanks on the same side. It's a little different. It just makes it easier to leave it in vertex form. The blank, the first blank, is exactly the same thing we've been doing. Half of this squared. Half of 4 squared, half of 8 is 4. 4 squared is 16. So I add 16 to here, because this is now my perfect square. Now, normally when we're dealing with equations, if I add 16 to one side and only add 16 to one side, I'm not balanced anymore, right? Normally what I would do is I would add 16 to the other side. But I can work with only one side and still maintain balance. If I add 16, what am I going to put in the other blank to keep my change as a net 0 change? I would put negative 16. If I add 16 and subtract 16 from the same side, what have I actually done to that side? I've actually done nothing. If I add it and take it away, what do I have? I have a 0 change, right? So here's what's going on. This portion here, this right here, that's my perfect square. Y equals x plus 4 squared. That's what that is. This part is my vertex. That gives me the y coordinate of my vertex. I am now in vertex form. So it's actually only a couple of steps to do this. It's fewer steps to do this. But it's a similar process, a very similar process. But it's fewer steps. I'm not done. I'm done. I'm not solving. I'm just rewriting it in a different way. I'm taking it from standard form into vertex form. That portion gives us this. That portion gives us that. If I add and subtract the same thing to one side, I have not changed any value. So let's do the next one together. My first step, just slide the 9 over. I'll do it down here a little bit. Y equals x squared minus 2x plus 9. Just slide it over. Give me a couple of blanks. What am I going to put in the blank? What completes my square? Half of negative 2. Square it. Half of negative 2 is negative 1. Square that, I get 1. So I add 1. And if I add 1, what do I need to do in the other one? Subtract 1. So now I get y equals, this is my perfect square, x minus 1 squared. Half of this, so it goes in there. And then the other part, plus 8. Ta-da! Okay. Not terribly difficult, actually easier than what we just got done doing, I think. But you can't do one without the other. You kind of have to know it's easier to know it. Okay, your turn. Do those. Okay, these ones don't take as long as the other ones do, so let's go ahead and do this. First step, move the 3 over. Y equals x squared minus 6x blank plus 3 blank. Fill in that blank. Half of negative 6 is negative 3 squared. I add 9, so I add 9 and I subtract 9, which means I have y equals x minus 3 squared minus 6. Same thing on the next one. Y equals x squared plus 4x blank minus 5. Fill in the blanks. Half of 4 is 2. 2 squared is 4. So I add 4, which means I have y equals x plus 2 squared minus 1. Okay, on the next one, y equals x squared minus 2x blank plus 9. Fill in that blank. Half of negative 2 is negative 1 squared. I get 1, so I add 1, and I subtract 1. Y equals x minus 1 squared plus 8. Same thing. Y equals x squared plus 10x blank minus 6. Half of 10 is 5. 5 squared is 25, so I add 25. And I subtract 25. Y equals x plus 5 squared minus 31. Any questions?